So this is the documentation, it's still work in progress. If you go on the page that is debdelta.debian.net and you click on the documentation, that's what you get. And
just a second, who's taking notes?
It looks like a mix of people.
So you volunteered? Or?
I can volunteer.
You can't or you can?
Sure, yeah.
All right, thank you very much.
Okay, so brief overview. Documentation is long, I will skip most parts, of course. And there are mainly 4 commands. One command is debdelta, that computes the delta, that is the difference between 2 binary packages. So you specify 2 different binary packages, and then this will make the delta. And sometimes the delta can be much smaller than the original packages. Then there is debpatch that applies the delta, so you specify the delta, the original package, and the rebuilt package. And if you put this slash instead of the original package, it will try to use the data from the installed version of the package. So you don't need to have the copy of the original package. Then there is debdeltas that does build the archive, the repository of deltas. And usually what it does is that currently if the delta is, let's say, more than 70% of the package, it throws it away and leaves a kind of stamp, and this can be discussed. It's not possibly optimal, but now it's this way. And then there is the most important piece for the users is Debdelta upgrade, and uses the above repository to help in upgrading. So you do apt-get update to get the new listing, then Debdelta upgrade, and then apt-get upgrade, and this will, possibly speed up the update. What this part does is that it analyzes the apt caches and tries to upgrade and sees what you would need, and then downloads the deltas and creates the debs.
And this is currently not using Python apt, it's a homegrown solution around apt-get, right?
Right, exactly. Okay. It simulates a apt-get dist upgrade.
Right.
So sometimes it breaks, and that's one problem that we would like to solve. And at the same time, also, it can download debs. If there is no delta for a package, then sometimes to keep busy, it also downloads some debs. You can customize it by this deb policy. Okay, and also I want to advertise this piece of code that I wrote a few years ago and never actually used it, and it's in the Git repository. And that forensics, what it does is it uses an SQLite database, and it keeps inside information about Debian binary packages. So when you add packages to the SQLite database, then it adds the list of containing files and some hashes, usually SHA-1. And then when you use the scan option, it will check if a file is a part of a package. And the idea was to have also a forensic that would scan the whole file system and tell you which files are coming from which packages, or if they are moved, or if somebody changed the permission and so on. And the idea is that when you use the Debdelta upgrade and you also pass it the debug option, then if it fails, it sends me a file that I can compare with this. I could compare with these databases to understand what went wrong, because the most important cause for failure usually is that the data of some file on your hard disk has changed for unknown reasons. And then, of course, it's impossible to build the package by delta in. And this happens sometimes, but the problem is that when I tried it, the databases were so huge that I couldn't possibly keep them up, and so I had to give up. But I wanted to advertise it because if this becomes part of a global solution given by Ubuntu or Debian, then hard disk space will not be a problem, so we could do it again. A very brief comment on what is inside the delta. The delta is an AR archive, and actually also debs are AR archives. And the first element is always an info, that is a text file, and will give you information about what the delta contains. And this is always the first one, for reasons that I will explain later on. Then there are some members that are by number, so 0, 1, 2, 3, 4, that are data. And then at a certain point you also find this, there is a compressed script shell, and then in the end also some signatures. And so the idea is that when you apply the delta, the script uses the data to end the old version of the Debian package to rebuild the new package. And using the script was good because it's very flexible, so I can rearrange the data in a lot of ways to use pipes and so on. And okay, I couldn't write the documentation for the info part, but I can explain it. And also let me tell that I cannot really explain now in short time how you apply the delta, but there is a simple script that shows you the steps. So it's easy to read it, and it actually works. I mean, at least it worked the last time I tried it. And so.
Before you move on, can I ask a quick question here about the
Yeah.
PPG signatures?
Yeah.
What do those sign? What do you support having signatures for? Is it signing the R, the script, all of the above?
Okay, so this is a weak point indeed. The signature signs the members of the R. So this is actually I copied from a package, a method that was called dpkg-sig that was proposed a lot of time ago as a way of signing archives, and then we used another way. So it's compatible with that one. So the weak point is that indeed it only checks for the members of the R, but if somebody embeds something else in the R archive, then that would not be signed. But I mean, as long as we trust the R tool to do the right thing and only extract those members, then it will be fine. But you're right, if you want to be really precise and sure about security, we should do it.
But as long as we sign the patch script, then everything else from there should be...
Exactly. As long as, for now, I would consider it secure enough. The patch script is signed, and the data that it is using are signed.
Right, and presumably the data...
The patch script is signed.
Yeah.
Okay.
And presumably the specific data components that the patch script uses are embedded as part of the patch script, right? Like,
Right.
it's not going to say, like, take all of the data components
No.
that are in the...
It uses only the part that was signed.
Okay.
If you add other data, it would be, actually I think I deleted it at a certain point.
And
Just-
is that easy to roll out for custom packages as well?
Sorry?
Is that easy to roll out for custom package?
The data, yeah, I will show it later on.
Sorry.
I did have a second question that goes with that is, what are the tools like to do the verification of signatures? Is there
The
integration?
Delta upgrade does the verification of signatures.
Sorry?
When you apply the patch for using the Delta upgrade, signatures are verified.
And it verifies them using the same key ring as apt?
No, there is a keyring inside the H and then the Delta and then keyring there. I didn't use since I did it all on my own, I couldn't use the official. I didn't want to mess with that.
So is the signature against the data.tar or is it against the data.tar of GZIP?
No, the data, that is not, I mean, part of the data. Then in the info part, you get MD5 that is used for integrity checks for all the results. So since I'm signing the info part as well, then when you build the dev, each and any part of the new dev will be checked. So I can guarantee integrity with this scheme. But I'm not signing the result in dev is, I mean, in a sense, it's signed by the fact that its integrity MD5 hashes are
So
signed.
it's creating the same .deb bit by bit for bit?
Yeah, exactly.
So you're reliant on having the same pre-compression
Yeah,
pipeline.
yeah.
The original script is compressed to it. So if it's an LZMA package or ARM, we have to fully recompress it in the same settings that the original deb was compressed with. So 32 megabyte block maximum compression or something. We have to recompress it in order to be able to recreate the deb. So this is why, for instance, with the so when Zedlin changes, this all explodes.
Yeah, that is in the interest point, but let me go on because it's in the documentation. Let me. Okay, so the service now works in this way, and so when you use that upgrade, what goes on behind is that there are two scripts that keep a complete, reasonably complete repository of Debian containing at least these two architectures because they cover over 70% of usage according to popularity contest. And then when I upgrade my local mirror, then I call Debdeltas and it creates all the deltas that may be used for upgrading. And now I'm covering Squeeze, Squeeze Security, Wheezy, SID, and Experimental. And actually deltas are not a lot of space on this, they are more or less 10 gigabytes. So let me also point that in a sense when you think of deltas there are two different goals. One is to have that you want to reduce the size of downloads. So for example for people that pay for the network that would be very poor. And the other one it would be like to be faster. But this is not completely compatible because for example the BSDIF tool, deltas contain and use standard Unix tools. BSDiff is very good at compressing, but it's very slow. So if I would use BSDiff, then I mean I could make it smaller, but it would be much slower. In particular, BSDiff does not work by blocks. For example, with bzip, usually you get 900 kilobytes of data at a time. BSDiff tries to load all of it in memory at once. So if you use a large chunk of data, then you will run out of memory. And it uses more or less 17 times the memory of the file that you are, so it's easy to run out of memory.
17?
17.
Wow.
Okay.
Yeah, even when applying the data. So it's, or maybe it's 10 when you apply and 17 when you, I don't remember. But it's, it uses too much memory. Also, the other point is that xdelta3 is capable of working on pipes, and BSDiff is not. So you can actually create, you can choose the backend by command line switch, but if you use BSDiff, then the patch is very different inside because it has to divide the data in chunks. Otherwise, if you use xdelta3, then it's just a huge pipe. So, the delta plane changes a lot.
When you say it doesn't work on pipes, is that actually, you're talking about it doesn't work in a streaming context, or that the tool itself doesn't handle pipes?
Right, BSDiff doesn't handle pipes.
Okay.
You cannot pipe the data inside and possibly also the patch, and then get the new data outside. With xdelta3, you can pipe everything inside and get pipes outside.
Okay.
And also another example is that the fact that many debs contain compressed stuff. So for example, there may be the changelogs is one example. So currently, Delta opens this and analyzes them, because when you, it's again in the documents later on, but let me tell it now. When you update the changelog, you add some lines at the top of it, and this changes the compression to the end. So it makes sense to open it, uncompress it, change it, and recompress it. And, but this is low again. For example, what I'm not doing this for the Linux source. When you download the Linux source, there is a huge tar bzip2, there is the source, and I'm not compressing and recompressing it, so it cannot be deltaed. If I would do it, then it would be extremely slow, but extremely small. But the point is that it would take a lot of time to do it. You would have to decompress the package, decompress the tar, diff the tar, recompress. So I don't know if it really makes sense. Also, there are not a lot of examples.
And it would be hard to generalize, I suppose. Because you would have to look inside the structure of each package, which is different.
Also, okay, let's go on.
It's not hard to generalize PNG images, zip files, jar files. They all have deep-late streams. And the question is whether you can work out what scheme is used to that file.
That I can do reasonably well.
So what you do is you test a bunch of default GZ options, and you test mini GZ with a bunch of default options.
Yeah.
Hopefully you have a hit. The problem comes that you are restricted to only being able to reproduce that subset if you can identify it.
Yeah, exactly. Okay, so let me also point that this simple example. So at a certain point, let's say 1st of March, then the repository contains foo_bar1. Then on 2nd March, there is foo_bar2 uploaded, and then on 3rd of March, foo_bar3. Then on 2nd of March, the server generates the delta from 1 to 2, and on 3rd of March, also the delta from 1 to 3, and from 2 to 3. And so when you upgrade on the 2nd of March, you would use 1 to 2, and then on the 2nd, 2 to 3. But if you do not upgrade, and you upgrade on 3rd of March, then you would directly use 1 to 3. Okay, this already said, I delete stuff, the deltas that are larger than 70% of their depth size, and this is a rule of thumb that may be improved. And I also do not generate deltas for packages that are very small, because it doesn't make a lot of sense. Okay, so also again on how their child works, the configuration file is this one. What it does is that when you want to upgrade a package, it looks at the release file and contains this kind of data, for example, origin is Debian, label is Debian security, and so on and so forth. Then it looks inside this file and understands where to look for deltas. And so it can build the delta name by putting package name, the old version, the new version, the architecture, and then the suffix, the extension. And the good point of this approach is that you don't really need indexes. Well, you of course need indexes of debs in APT. You don't need indexes of, at least not for this purpose, of deltas, because when you know the name of the package, the old version, the new version, then you build the address by putting the pool structure, and then this, you build this, and then you try it. If it's there, okay. If it's not there, then too bad. So that for me is a good point, because I mean, we all know that downloading indexes takes a lot of time. So then PDIFs were added, but that was slow, and so I mean, in the end, if it takes 40 seconds to update the index of deltas, and then it takes 3 seconds to generate deltas, that doesn't really make a lot of sense. I mean, then you just download the deb, because in 40 seconds you download the deb. So now I'm trying not to use indexes. These are some side effects, but.
Well, that means you have to make an extra request.
Yeah. Yeah.
To know if there's a delta available.
Yeah. The problem, okay, is that this is not very nice on servers, because everybody is asking for packages that are not there. So servers get a lot of 404. If this is a problem for servers,
well, there's also an issue that you can't determine before the fact how much data you need to download in order to apply the update.
Yeah, that progress reporting, you cannot do it by data, more or less. Let me go back to this in a...
You can upper bound it, obviously.
Yeah, no, but there is a trick. Okay, so let me mention one fact, is that currently there is no way of doing incremental upgrades. It will never happen that when you want to go from version 1 to 3 of foobar, you use first foobar 1 to 2 and then foobar 2 to 3. Because this doesn't make sense for many reasons. One reason is that unfortunately deltas are large now. So if you take 2 deltas, they are extremely large, so it doesn't make sense. And then also it takes too much time, so it's against the speed idea. And also the server is already made up to build the intermediate, the 1 to 3, so I mean. And also this would need indexes, because you would need to know that the intermediate version was 2, and you don't know. So currently there are no incremental, okay. Okay, so this is going to be late. This already more or less said that this is how I build the repository, let's skip it. And okay, so if somebody wants to implement a repository of deltas, there are 2 ways. One is this way that more or less already told you, is that you keep a full mirror and then use one of those scripts that I was pointing, like this one. And then this script helps you in updating the mirror and then building all the deltas for it. And this, I mean, maybe it's not the correct way to put it into, I mean, a repository server that has the, I mean, when I tried to propose it to the FTP master people in Debian, they didn't like it. But so another way that I could propose is this one. Let's say that I write 2 commands, 2 hooks in a sense. One is schedules the building of deltas, and the other one saves all the files. The idea is that when DAC, for example, is adding something to a pool, then it would say to Debdelta, okay, I'm adding this file, and this is added to testing main AMD64. And then at a certain point, and DAC doesn't need to care about it, the delta will be built. And the other one is that when it delays something from the archives, a deb, then this would be saved, because I need all versions. And then again, I could build some database, and I keep track of it. And then, I mean, I would copy it, so I would need some temporary space. This is actually what I was doing up to 1 year ago. And I know that, I mean, this needs more or less 30, 40 gigabytes of space for the old debs, if you want to keep a 10-day window of deltas. So if you want to enable people to upgrade by deltas for a 10-day time in a fastly moving situation like Debian testing or Debian unstable.
How many architectures does that include, the 34 gigs? Is that all architectures? Is that
2. This is always, I always do it only for 2 architectures because of size limits. I'm not so sure that people using ARM would benefit from it, because ARM is not going to be so fast as to, I mean, defeat a good ADSL connection using deltas. But this may be benchmarked. Okay. Okay, so goals and tricks and ideas and issues and everything else. So first of all, as I told you, the idea is that when used in the standard way, the rebuilt deb is identical to the one that you wanted to download. And so you could check it by the security features in APT. I was later told that APT doesn't check it.
Well, it does, while downloading.
While downloading, but not if it finds it in the file system.
It assumes,
It assumes, but anyway, I'm checking signatures and integrity, so I mean, I know that it is identical. But also, if you want to use it to build a repository, then you know that each signature in the repository local repository will be identical to what you would expect, so it would work.
It's a root-owned file. It's in a root-owned directory. You know, if somebody smuggles in a file,
We haven't deployed this stuff years ago. I didn't know.
Anyway, the other point that I was telling you is that there is some mechanism for exact recompression of stuff, and since I want to have exact patching, then I need also to exactly rebuild stuff by unzipping and gzipping. Back in this, I do more or less what he was explaining before. I check what kind of tool was used, I figure out, and then I do it. And usually it works, not always, but I mean, when I try to look, it works.
What happens when it doesn't work?
Gives up. Instead, so for example, if the changelog.gz cannot be recompressed by a tool so that it becomes identical to the new version,
We are
then it will.
solving that for multi-arch.
Ah, okay.
Because multi-arch requires changelog.gz to be identical between, at least for library packages, this is being solved.
Yeah.
And, you know, for instance, Dev helper has used gzip-nf forever.
Yeah.
To make sure that, you know, you don't have timestamps in file names.
Yeah.
We-
No, but I can work around timestamps. I studied the header, so
This is just an optimization, right? So
Right.
basically, we try to do this, and if for whatever reason it doesn't work, it falls back on just doing it via stick or whatever across the entire thing instead.
exactly. So if it fails, it's not that the delta is fails. It's just that that will not be analyzed as a gzip, ungzip file. It will be passed to BSD or X-Delta3. So it goes on, and you will lose some quality of the resulting. The size will be larger.
Complete curiosity, does it buy you a lot?
Yeah, sometimes there are documentation packages where in each document at the top there is an LCS, a version number, then they release another version and they change it and all the documents change.
So
So in essence, these are the streaming context. If you add a new changelog.
Oh, no, I
entry-
completely
Yeah.
understand that, I'm just
Yeah.
saying, in general, over the large archive size and everything, does this gain you more than something
On the
that-
large archive, I don't know, but I could show you one example. That's when I started coding
Okay.
it a few years ago,
That's
which,
fine.
I mean, there was almost no change, but the delta was huge. And then I implemented it, and all the documents were perfectly, analyzed, and then the delta was reasonably.
It's the same situation as Ocelot, okay? So
Yeah, no, I completely understand the problem, I'm just,
generally did two things without any knowledge about what they are.
right,
You
yeah.
just end up different binary data that have no relation to each other. So be it executables or be it gzip files, if you want to get effective dips, you need to understand what they
Yes.
decide. You
I-
need to understand their structure.
Yeah, no, I completely understand, I was just wondering overall
Okay.
what it gains.
Oh, I can show you in case if you're curious. So these are old numbers, 2006, but more or less at the time what I could achieve was that when I build the delta, in a sense what I'm doing is I'm chewing the data at 900 kilobytes per second, and when I apply it, it was going at the time with those kind of CPUs at 600 kilobytes per second, and then if the ADSL line goes at 80 kilobytes and you do some math, you realize that when you use the delta for that file, you're going to use let's say 1,400 seconds instead of 4,000 seconds. Let's skip over all the math. You can do some simple computation to see that with slow network it pays. With fast network it doesn't. And if you use the data upgrade with the verbose, the command line option, then you can actually see all these numbers for all your downloads, and it will tell you how long it took for each one of the deltas to download the delta to create a new deb, and then it will summarize it and tell you for each one of those steps how much it took. Okay. Okay. Now the problem is that I would like to speed it up, and so there are a few ideas. Some of them are implemented, some are not, and so. One idea is that while I am downloading, as soon as I get the delta, I start applying it. And that's, reasonable. Also, in the deltas, now I'm using pipes as much as possible. So when the delta, when you apply it and the patch script is running, it is fetching data from the hard disk, and at the same time it is processing it using, let's say, X-Delta3. So this is, of course, speeding stuff up. It's trying to keep both the CPU and the hard disk busy as much as possible. Okay, so that summarizing
I have
it.
a question about something you wrote there which says you download the dips in order of increasing size.
Yeah,
You
okay.
have to have queried.
Okay,
for each of them
this is
side by side, right?
this section. Actually, I download in two steps. In the first step, I download the part. I use the HTTP query to ask for the first 10 kilobytes of the file. 10 kilobytes is again a magic number, but the point is that half of the repository of deltas, half of it are less than 10 kilobytes. So first of all, 1/2, you get it completely. And then you start applying it immediately. Then, since the info file is at the beginning of the delta, you also get the information inside of it. And then you can do a lot of things. For example, you can do progress reporting about the downloading of the rest, because then you know how large they are. HTTP tells you how big the delta is, but also the info section tells you. So at that point, you get some information that otherwise you would get by index files.
Okay, so you're optimizing to reduce the round trips by, you download the first 10K and
Yeah.
most of the time that gives you everything you need.
Yeah. 10K is also, kind of compromise between asking not enough so that the server is, moving head on the disk too much for no reason, and asking too much and then it takes too much time. But it should be customized depending on the speed of your network, and this is not, I'm not doing. Because if the network is low, you would ask for less. And if the network is that you could write down a math formula, but that goes into the to-do list of benchmarking. I didn't ever have time to do all of this coding. Okay. And that is the problem is that now there is this rule of 70%, and no delta exists that is larger than 70% of the deb. But actually what would be nice would be if there was some kind of prediction scheme, so that when you know the information about how the delta is structured, then you should choose if you want to go on downloading that delta and then applying it, or if you just give up and you download the deb, and that depends on your hard disk, your CPU, and other data. And actually I built some code in the predictor class, but then it was not working very well. It's not easy. There are too many factors, and if somebody wants to work on it, it would be nice. And then in that case, if this predictor class would work very well, then of course I would move this on the server side to 99%, and then it would be the client side who would decide. In the first step, if it's less than 10 kilobytes, who cares? But if it's more, then you would decide, let's go on and download the rest, or let's give up.
When you've got local files that change, how easy can you fail? How quickly can you fail and know that you're going to have to fetch things?
Sorry, I didn't.
When you've got an incomplete set of local source files or modified local source files attached against, how quickly can you bail out and realise that you're just going to fetch the
You mean how quickly the predictor class would work?
So
The decision or the applying of the
you've got A locally and you've got a patch against A to make B remote.
Yeah.
If A has changed, B won't depart.
Why would A
Right. I think maybe you're missing something, right? This does not work against the installed files on your file system. The expectation is that the client will have a complete cache of all the corresponding .debs for the installed system.
No. This uses the installed files. The assumption is that everything that is not a configuration file has not changed. This uses the installed files. So, the delta and the deltas are tested actually in the server. So if your local files are not changed, the installed local files, then it will work. It must work, unless there is something really strange going on.
Wait, when you started the discussion, you said that the Debdelta tool takes two binary packages, generates Debdelta. Debpatch takes the package and the delta and generates.
Yeah, but if you the patch, if you put the slash, it uses the installed version of the files.
I see. Do we currently clean up the apt cache in the meantime?
We do. Yeah, there's a cron job. It keeps it only for a certain amount of time.
Default 2 weeks, I think.
Yeah. And
Yeah, at a certain point somebody asked me, why don't you use the cached version of the deb? And the reason again is speed, because it takes time to unpack it. Yeah, instead, when I build, what I need is a tree of data so that the patching script then finds it. And if the data is already on the hard disk, there is a tree of symlinks.
So if,
So now, Sladen's question, if one of the files has been modified on the system, how soon will you notice this and realize that you need to bail?
When it fails.
Right at the end.
Right at the end.
So
To do it before, you would do
So we can
So
potentially down to 170%.
If
Yeah.
people are doing things they shouldn't be doing, the packages on
Exactly.
We can verify that before downloading anything if we use the MD5 sums or anything like that, right?
MD5 sums are not guaranteed as part of the package. That's a packaging construct which is used by the majority of packages.
Right, there's an extraordinarily
And-
large percentage these days that ships.
Yeah.
But even on our most basic system, like an MD5, like that checks on your MD5 sums will fail because some files are missing, some files are modified. It's currently it's not great.
That you're modifying local file while you're doing a Debdelta update.
Okay, but let me point out that this happens very rarely. Okay, so there are, in 5 years I saw two situations. One situation you use locale purge or a trick like that to delete all your locale files. Then it will always fail, no way. Other situation you don't, then it will almost always succeed. With some few exceptions that I've coded in the server, so the server knows them. There are a few packages around that have this bad idea of changing some local file that is not a configuration file, but I listed them, and the deltas know them, and they don't use them.
How does Debdelta deal with conf files specifically then?
It ignores them. In a sense, you can think that the delta contains a verbatim copy of them, in a sense. Or they are, I mean, X delta 3 in the piping doesn't see them and somehow compresses them. Anyway, they are ignored. Because, I mean, those are...
So it just includes a pristine
Right.
So from my perspective, penalizing people who have modified files in the system that are owned by packages,
That's more of this is
that what?
It happens with local ones, it's also
Oh, so you're talking about corruption sources.
Yeah, but then we'll have hardware failures.
Yeah.
I mean, that's probably that'll be downloading 170% if they've got hard disk corruption is probably going to be the least of their worries.
Yeah.
I think so too.
But I
Also, you could check MD5 official and MD5 before you start applying the patch, but that would take time, and since these failures are very rare, I wouldn't do it.
So
I would
my
go on and
concern-
assume that it will work.
My bigger concern is there any risk that in the process of applying a delta to an existing package, that if it's a file that has not been modified between the two versions, is there a risk that we end up with a corrupted deb install, where Debdelta in the process of applying the patch says it takes in the file that was on the disk. Because it's not been modified as part of between the two versions, it does not recognize that it's been corrupted.
No, when it produces deb, then at the end it checks an MD5 integrity on the deb.
Okay.
So the deb is guaranteed to be fine.
Okay.
Sorry.
What proportion of the effort here is in recompressing the output?
Okay, let's go to that. Okay, so now the problem is speeds for me, and size also, but let's say speed. And the problem of, let me tell you why speed is a problem now is that if you use X delta 3 on, for example, on this CPU, on uncompressed data, then it will go for 2 megabytes a second. But then the data inside the deb are compressed by a factor of 3, so what you actually see is that the speed on the compressed data by proportion is still 700 kilobytes. So what is happening is that since packages are switching from gzip to bzip2 to LZMA, then in a sense the deltas are running slower now. Because, I mean, in a sense, the tool that works on uncompressed data then has to, and then this is again a situation against the quality, because packages are smaller, and so the delta in proportion looks larger. And this is what is, in the past when I started using, the deltas were on average 25% of the debts, and now they are 40%. And I think the main reason is this one, plus another one that I will explain later on.
The MD5 sum that you do is against the uncompressed data at that point?
In the standard situation, it's the compressed data. The final deb, from the beginning to the end, all complete. Checks the size and the MD5. Usually, if it fails the size, it fails immediately. So you don't check the MD5. Okay. Let me mention another point. I wouldn't use currently Debdelta to do some kind of long-time archiving because it relays on Unix tools, and from time to time this changes. So if you prepare Delta now, don't expect it to work in 10 years because one of these may change, or either the output or the command line invocation, and that it will not apply. But for everyday usage, like we read Delta a week ago and we applied it now, it's fine. And when it happened that one of those tools changed, I adapted Delta, and in 2 days it was working again. So for now it works fine. But if you want to use it for archiving, you should save a copy of this somewhere. And be sure to use exactly that kind of, okay. Okay, so how do we make it faster? So this is more or less what he was asking. And one idea is streaming. The point is that when the Delta now builds up the new deb, it recompresses the data part. And that takes time. Then it passes it to dpkg, and that uncompresses it immediately after, so it doesn't make a lot of sense.
Right, so here's where we get to the issue is whether we sign content or the encoding of the content.
Okay.
This is why no Delta stuff has been deployed for 5 years. It's because we signed the .dems, right? Which is a particular encoding with a particular encoder with a particular set of settings.
Since the last week I encoded.
Right, but when you're installing one of these Debdeltas, the signature that you are relying on is a signature on the Debdelta, and the Debdelta refers to the checksum, the cryptographic hash of the .deb that is to be constructed.
Not only. Since last week, it also contains the checksums of the individual parts uncompressed.
Right, but it does. But the thing that you're relying on is the cryptographic checksum of the resulting .deb, and you have made the design decision that the resulting .deb that you get out of this is the same as the .deb that you started with. But if you chose instead to generate a delta that produced an uncompressed data tar.
That's one. Exactly. This format was introduced last week, and this generates a deb that is uncompressed and checks integrity on the single parts. So this one is actually faster. I cannot tell you how much.
You don't need to check the integrity on the single parts. What you do is you.
Why not?
When you're generating the delta, you take the original .deb that was signed and you strip off the signature, uncompress the data.tar, and now you've got your new target deb.
No, but there is, I mean, once you
because
give
then
up,
you know that you've got an end-to-end checksum, right? The problem with all of this is that it's a bit kind of...
So what you're interested in there is getting just the content.
Right. When you use that format, you give up the idea that the deb is identical to the one that you wanted, because it will not be, because it will be uncompressed. So, I mean, it doesn't make a lot of sense to check the whole of it, you just check the content, and the content is checked. So, in that format, generation of deltas is, applying of delta to generate debs is much faster. And I expect it to be much faster also when you apply it, when you install it with dpkg. But I cannot provide benchmarks, okay? It's been around a week. Actually, I implemented the server-side part a week ago, so the patch can do it. And so some packages still are not, I mean, up to date. So when you try it, sometimes it says, no, I cannot do it for this one because it's the old version. Otherwise, it does.
What are you using to compress the individual diffs? Like in your delta, which compression algorithms are you using?
Or X delta 3, depends on command line choice. Now X delta 3 mostly.
That's a. Does that have compression built in, or is that just a way?
Yeah, it has compression, but one thing that I want to ask to the upstream is to add LZMA compression, because it shows. I have examples showing that that's what we need now. Otherwise, it will. Okay, I cannot diverge too much from. Okay, so since you were also liking this idea yesterday, you in particular, I also implemented this one yesterday.
It's quite impressive.
Okay. So this one, instead, what it does, it creates a deb where instead of the data tar part, there is a data list, and then it writes, it would write, it doesn't now because it's just a proof of concept, the regular files on the hard disk. And then in the data list, you see a list of what was in the tar, and you decide what you want to do. So dpkg would look at it and, pretend it is a tar file and install. For example, this is a list I generated yesterday. So you would get directory, mode, ownership group, modification time, then new file name, but this is not a file, what the tar was saying for the name, and link name if it was a link. Then it is a regular file, it was uncompressed in this position, and then this is what the tar said it was the original name, and okay, this is a symbolic link, and then the symbolic link has to have the it was not, no data was put on a hard disk, and this was the link target, and so on. Okay.
So in the general case, that has to, it will actually have to do copies of that data that you've written out to disk. We'll still have to copy them into a final destination in the file system as part of the dev installation.
Yeah.
Because you're not guaranteed to be on the same file system, so the package has to be robust and still do a file copy.
That is a design choice. This is a proof of concept.
Sure.
We could put it in a temporary place, and then if it's not in the same file system, it will be copied, or we could guess, I could put in the Delta code to guess for each destination, which is the file system, put it somewhere, put it in the same directory with the extension. As you see, I'm putting some, when I unpack it, I'm putting some extensions to be sure that this is unique.
Right,
and
the thing that you haven't listed as a con is the fact that this is like an enormous layering violation and will involve doing considerable violence to code that's already rather too complicated.
Yeah.
I think what you're saying is this should be in dpackage, right?
You'd have to do it in dpackage for it to work, and you wouldn't want to put it there because, like, you know, the number of bugs you will introduce.
Well, this is a compromise, right? So this pre-unpacking is done in Debdelta. And then dpkg, instead of, scanning the data tar would scan that description. And then it will react exactly. This is more or less what you get when you scan a tar. So, you would have to change in dpkg only the part that opens the data tar part.
Well, no, because if what you're trying to do is to avoid having dpkg read the data off this pre-unpacked file and write it out again to another file in the same directory, pointlessly, which is the only reason you might want to do this. Otherwise, you would just write off into var somewhere as a .deb. You don't lose anything. So if you're trying to avoid that extra disk-to-disk copy, then you have to go and fiddle with the code in dpackage that deals with handling the .new files and renaming things in the right order and making hard links and stuff, which you don't want to do.
Well, it was proof of concept.
Well, it seems like the right place. It seems like dpackage should be like what we talked about was having like a ddeb is taken, unfortunately, but having a delta deb, which is not a deb in itself, but dpackage can act on it, and it would basically do what the shell script is currently doing as proper C, and with all the magic that dpackage currently has in order to ensure as atomic changes as possible.
The easiest thing to do is simply allow uncompressed .debs.
No, this already works.
Exactly, right?
Yeah.
It's currently the spec doesn't allow it, right? The easiest thing is to allow just a .deb.
Why do we say this?
Because
And the control data is tiny.
Yeah, it's a tiny thing, but that was the block, and that was still the block the users get. If you just
fix
make
that.
the uncompressed .deb with uncompressed data.tar, the exact same code path that currently works, you can like that.
No, but you shouldn't talk in conditional. This is working.
Yeah, and you don't need to worry about the kind of basic changes that
Yeah.
I've seen in this game.
So that was the previous
Right.
slide up there.
Exactly.
Right, but there's
This works.
right, but
You
what you're
can
doing
really
there is
start
you're not checksumming the hypothetical uncompressed deb. You're checksumming the inputs, effectively.
Checksumming, I thought he was checksumming the data.tar unpacked.
Yeah, that's it.
If you're checksumming each of the components of the R, do you care about a checksum of the .deb?
No. Not integrity.
Checksumming is for integrity in this case, not for security.
Right, from a security point of view, well, you also want to make sure that the resulting package, if you are going to now install it, is the same one that the person who generated the delta intended.
Yeah.
Do you want that as an automatic routine to verify, or will it be left to the user to verify behind that?
Sorry.
I certainly think it should be automated. That you're
Absolutely.
verifying the integrity.
Yeah.
And
These are automatically verified.
So-
after the delta.
Well, yeah, I think we're in violent agreement. Nobody cares about whether the .deb is byte for byte identical to the original. What we care about is that the contents are correct,
Absolutely.
which includes both the control.tar.gz and the data.tar.
Yeah.
So, you only care for the complete deb if you want to put it somewhere in a repository that people will download.
Right.
So if you don't provide format unzipped or format pre-unpacked, that will be true actually.
Right.
But if you provide those, then it will not be
Well,
true.
it would be possible maybe for something like apt cacher to generate these uncompressed debs on the fly. And if your apt cacher is on a local network, it's probably faster to provide an uncompressed package and then install it on your...
So that is brilliant, because I think we had some requests coming up that way, and particularly because as well apt-cacher NG use a different spool as well than the normal apt. And this is useful for people, for example, that are on 3G and needs to do part upgrade of the machine in several parts, because they're on 3G and they don't have the data and it's on the 200 megabytes per day.
But when you're using apt-cacher, you do have an untrusted network commonly in the path, and we rely on apt checksum validation to integrity.
It seems like you almost want to come up with some way to include the checksums for the uncompressed data in like the packages file within the normal apt repositories, and you can mirror them safely.
Yeah, it's almost like you want to sign the content.
It is.
Surprisingly. Somewhere.
In any case,
buy-in from the buildings, this requires buy-in from the FTP masters, and this requires thing. And this is the reason things happen.
Well, by the way, I just got a wish list bug for that mirror, for the same reason.
Right.
That mirror would be another choice. I mean, but for some situation, FT cache would be better because you don't want to keep the whole mirror. You just need what you want to install on your local machines, and then you ask FT cache, and then it invokes the delta, and they get the new. And
I agree with the two use cases. People will have repo on site will want it effectively as their mirror.
I don't agree that you need buy-in from the building. Because packages generation, the package.gz, and the file that we do all the checks and verification through is maintained entirely by the FTP master. So you just need agreement between app maintainers and FTP masters.
So all about like quickly downloading those checksums, effectively having them locally, using that as a reference.
If what you're proposing is to put in the packages file, which is the current trust path, the checksum, a single checksum of some...
It doesn't, strictly speaking, need to go in the packages file. We've got a new file if we want.
Right.
Yeah, exactly.
Did you want to continue, please?
If you had a checksum that was somehow a checksum of the canonical representation of the data in the .deb rather than the file name.
So what you want is a checksum that you recurse through the whole of the TARs or the PNGs inside them, or things inside them. You uncompress them all, and you create a nice linear theoretical uncompressed .tar, and you put that in the R. Right? So this is perfectly a legal .deb. It's just a very big one. Okay? And you sign that. And you store that signature in a packages that something are published in the same location. Right. And this enables, once you've got that, you've got a signature on your content, it enables you to do this, it enables you to use Z-Sync, it enables you to do all sorts of things.
So are you proposing that you would go, that the signature in question would be generated over a hypothetical file containing user blagle changelog rather than changelog.gz?
Yes.
But by the way, then you would have two trust paths working at the same time, because also the delta has signatures and is already, when you use it, is already checking by some integrity that is in the info file that is signed, is already checking the content. So yeah, that you would gain twice the same result.
I think the proposal here is to replace your separate certificate infrastructure with reuse of the new thing that we're now proposing, which Sladen thinks is useful anyway.
But I cannot throw away the signatures because I cannot trust stuff coming from the internet anyway, because there is a patch script inside. So I have to sign the delta. There must be a signature in the delta anyway.
There's two different signatures. One is whatever method is used, was it this or some of the other delta compression methods, knowing that the data coming in is good. One is knowing that the data you're handing off after your process is run is good to the user.
Okay.
So one is the user knowing that what the operating system code provided is what they're intending to install. One is you knowing that your program is not robust and it needs to deal with unrobust internet source data. Those are two separate things.
Okay. Okay, quick to-do, because we are over with time. So there is a Google Summer of Code for integrating deltas into APT. And then, as I already said, it would be nice to have some way of predicting if it would be better to download the Delta or the Debian package. One simple thing is that I use only one patching thread in the Debdelta upgrade. I would like to have as many as there are CPU cores. And then the Vogt asked me to, there is a new libapt for Python, and I have to, then I should support multi-arch. There is no multi-arch support. And then what I was saying before is that a lot of the numbers that I told you are a little bit magic, and I couldn't ever collect enough data and doing benchmarks to really understand what is the correct number, and so I don't have enough forces to do it. And also possibly implement the long time recovery if somebody wants to use it for archiving for a long time and having smaller archives, but this is a minor to do. And let me point to this fact is important. What happened lately is that when Debian switched from VCC 4.4 to 4.5, deltas became very bad. Because even doing a binary non-maintainer upload, the binary package would be so different that the delta would be huge. And in particular, it would happen that even if I use bsdiff on the old and the new binary, then the result would be larger than just using LZMA on the new binary. That is crazy. And there was a project, the Google Courgette project, that would analyze binary code and solve the fact that when you recompress stuff, when you rebuild and you use ZCC, a newer ZCC, then the code looks too different. But then they were hit with patent infringement. And so we are stuck on this. In particular, this is true for 386. For AMD 64, it's a little bit better. There is some, I don't know assembler code very well, but there is some point in how the pointers are used so that if the compiler changes optimization, moves the code around, then it looks completely different.
So
and
if anyone's curious, Courgette is basically an x86 disassembler that tries to completely understand the structure of the code segments. So you get hypothetical assembly code. You did that to acknowledge that the pointers are relative instead of absolute.
And it does match it to codes that you actually know to detect pattern.
Yeah, and there's a few other people who've done this, like there's the BJC processor that's in that's on.
People black that.
Yeah, there's a bunch of this. Microsoft has been doing it for about 15 years. It's a preprocessor. So you apply the preprocessor, you try and get back to as close to raw content as you can, you get to raw content, you reverse the whole stack of operations, and then you...
Yeah. So if you find one of those tools that is free of patents and you give it to me, I will put it into the deltas and we will gain a lot of quality.
So
that sounds like...
You used to, in this case, have a non-fixed pipeline, so you've got a shell script company that things like advanced com, again, that's a name, that has a stack of pre-filters that you can apply, pre-processors that you can apply, and then you do your business and then you do the opposite. So if you're on ARM, for instance, you need to pre-process that differently to understand the structure of the ARM instructions. So you do it with x86 code.
So we have very little time left, and thank you very much for presenting this. You gave us a lot of good information here. I wonder if there are any action items that we can take away from this.
I would, like, I don't know about you, but I mean, it was great to know exactly what's going on, but I would love to have another session and talk about specific, like what we can do. You know, talking about stuff like where should this live in Ubuntu, what needs to be done on the client side, and so on. So
and where should it live as well? Because I think, I mean, apart from the technicality, there is a question of integrity of having it not in the packaging.
Yeah, there are technical stuff that we...
Should I try to get another session scheduled for tomorrow?
That would be great.
Yeah.
I'll see if I can get down.
So the Summer of Code project is for libapt PKG integration?
Yeah, well, yeah, libapt and Debdelta integration, basically. You know, I mean, stuff like... Yeah. So it does make a lot of sense to have the same mechanism that downloads steps.
Yeah.
Downloading deltas as well.
Would we have to, like, if we're using the PKG acquire class, do you think we'd have to change to using a different class, or be able to put it in there?
Yeah, not having to change it. I mean, it would probably be like we can do it. Like we can talk about it. Like I don't want to, you know, prevent people from having lunch. Don't
worry about that.
I know that.